Now, in this example, we'll see how we use the chain rule to differentiate two expressions like this, two equations like this. Okay, so one way you can think about it think about the chain rule is to think about it in terms of like layers. Okay, so you differentiate layers by layers. All right, so let me demonstrate to you what I'm talking about. So for example, the first example, part 1, y is equal to 3x squared plus 5x minus 2. Okay, the entire thing to the power 5. So the first layer is the power layer. Okay, so you can see it's the outer layer, all right, which is the power. So when you differentiate, okay, like I said earlier on in the previous video, we'll think of this like as though it's an x. So when you differentiate x to the power 5, we do it as per normal. We bring down the 5, okay, and the entire bracket remains unchanged. Okay, don't touch anything inside. It is the same, exactly the same, but power reduces by 4. Sorry, it reduces by 1 and become 4. Okay, so this is the differentiate of the first layer. All right, so you differentiate the first layer. Okay, followed by the second layer, which is the inner layer, the inside. All right, so you got to differentiate the inside now. So you multiply by the differentiate of the inside, which will give you your 6x plus 5. Okay, so there you go. This is it. This is the correct derivative of this equation. Okay, but generally, usually, you won't be able to leave your answer just like this, right? You have to simplify a little. So your 5 and this 6x plus 5 can be further simplified. So it becomes 30x plus 25. So multiply in the 5. And of course, this 3x squared plus 5x and minus 2, entire thing raised to the power of 4. This entire thing, don't touch it. Okay, don't do anything to it because you're not going to expand it anyway. So there you go. This is it. This is the solution, the answer to uh, this question. Okay, so let's move on to part 2. All right, part 2 is generally about the same, except that it is in fraction form. So it is not that difficult because in this fraction form, all you need to do is to change it to index form. Okay, so you rewrite the fraction as a, as a term like this with power -1. Okay, and of course, what we're going to do, we're going to see this as though it's a two-layer thing again. So the first layer being the power layer, and then after that, we're going to differentiate the inside. So, all right, the first step is to apply the chain rule. So we bring down the -1, it becomes a -2, and then we have x squared plus 2, the entire thing to the power of -2. And we have to differentiate the inside now, okay, which will give us our 2x. Okay, so you just need to remember that in chain rule there's another step, and that is to differentiate the inside. So think of it like layers after layers. Eventually, when we talk about the derivative of trigonometric functions, okay, this idea of a layer by layer thing will come in pretty handy. Okay, of course, you can't possibly leave your answer this way. So bear in mind that this entire thing, which is having a power of -2, okay, is actually a fraction. Okay, so this is actually 1 over. So the entire answer would then become -4x will be at the numerator, and the denominator will be x squared plus 2, the entire thing square. Okay, so as you can see, the chain rule isn't anything that challenging after all. Right? It's just something pretty easy and pretty important because it is forever being there. All right, it's forever there for you to use whenever you need to use. Okay.